Next, I'm going to introduce the basic command line tools and the concepts listed in our course website in this section. These tools are more towards the fundamental and the basic tools. We also maintain a list of more modern, more edgy, more newish tool near the bottom of our course website, right here. But right now, we are going to first introduce the more basic or essential tools. Before we introduce these tools, let me first show you a few ways to access to the command line interface. One of the easiest way to do that is using Colab. If you have a subscription to the Colab, then it has an icon, a terminal icon near the bottom left side. So if you press this icon, then you will get a terminal right here. So you can do all the terminal commands. Another way to do that is to use your system's terminal. If you are using Linux, you just search for a terminal app, then you will find one. No matter you are using a GNOME desktop or using a KDE desktop environment, they all provide some applications that works as a terminal. The same thing is true for Mac. Mac also comes with a terminal. You can also install other terminal applications, some third-party terminal applications, if you prefer. Okay, in Windows, things got a little bit difficult, more complicated, because by default, Windows does not have a Unix or Linux-like environment. So there are two ways to get one. So one way is to install the Git bash. When you install Git, Windows version of Git, you will get a bash, B-A-S-H. Bash is a shell. That is very popular one. So after you install the Git with Git bash, then you can use your Windows Terminal app to open a new terminal, a new window that has a bash environment. I'm not using Git bash, although I also installed the Git and it comes with a bash. But in this computer, although it is a Windows, I'm using a more complicated setting. So I'm installing MSYS2, which can be considered as a more complicated or more complete version of the Git bash. It comes with a lot of tools and has its own package manager to install things. But as you can see, it looks like a terminal the bash interface. So I'm actually using bash right now. So it is a bash running on Windows. I'm not sure. I didn't install ZSH here. Another way to access to a full Linux environment is to install WSL, Windows Subsystem Linux. After you install the Windows Subsystem Linux, right now you probably can install it from the App Store, Microsoft App Store. I forgot Microsoft Store. The Microsoft Store. You can find the Linux or Ubuntu. Just install it, then it will automatically appear. in your terminal options. So right here, this Ubuntu is exactly the Linux system running inside the Windows. Compared to the Git Bash or MSYS2, this one is a fully Linux system. The Git Bash is actually a shell that runs on Windows, provides some compatibility layer to the Linux, but itself is still Windows. However, WSL or Windows Subsystem Linux is a fully it's just a full Linux. It still has some difference to the native Linux system, but they are close enough. So here, I think I'm running a VSH. No, a lot of my system running VSH, but this one is still running Bash, which is good because I think for the educational purpose, introducing Bash is more is better because it is more basic and sort of more fundamental, and I think it is still much popular than VSH in the sense that how many machines are installed with it. But a lot of people, a lot of developers prefer some newer shell like ZSH or Fish or maybe a few others. But Bash is still considered as a standard. Okay, another way to access to these shells is using Visual Studio Code, and this is what I'm going to use. If you are running it on a Linux machine or on a Mac machine, you can use it to open a shell by compressing Control backtick. So you can have a terminal right here. This is a terminal emulator and running a shell right here. If you are on a Windows, you can still use VS Code as your terminal emulator. It just you still need to install the WSL or the Bash, or you have to use SSH to connect to a remote machine, and VS Code allow you to do that by using the remote explorer. Okay, so right now I'm connect to my WSL, Windows Subsystem Linux. The reason that I'm going to use VS Code as my terminal emulator is because I can use Copilot chat right here. You can also use Cursor. Cursor is famous for its AI capability. However, in my experience on the terminal use on Windows, it has a trouble, an issue. I believe it is probably my fault because I'm not that familiar with Cursor. But the thing is, one of the very common function I use is to use Control L to clear a screen. So let me first list the files, which I will go into detail just a moment. But just let me fill the screen with something. Maybe I use find. So one very easy way to clear up the screen, the terminal screen, is to press the key Control and L together. When I do so, I clear the screen and I can go to the top to the top row and run my other command again, like this one or other thing. However, in Windows, on Windows, and when we use cursor, the Control L is going to call the pop-up of the AI assistant. So because cursor has a lot of AI functionalities, so kind of like the chat, but it has more ways to call up the AI assistant. One way is to use the shortcut Control L, so it's the same shortcut. It works pretty well when you're editing the Python files or C++ files or other files, but in the use of terminal, I find myself often press the shortcut Control L when I try to clear the screen, but it doesn't achieve. Of course, it doesn't achieve the result I was expected, because it just the pop-up, the AI pop-up just show up. Of course, I can use like clear to clear screen using a command, but I'm so used to this shortcut, so it's kind of a little bit of trouble. But aside from that one inconvenience, and probably that was my fault, but aside from that inconvenience, you can use the cursor as well, and you will have AI assistance just in your hand, and maybe even easier. Okay, so but this is my setting. I'm using VS Code and I'm using the GitHub Pilot chat on the left side so that I can ask the questions when I'm not fully sure what I'm doing or when I get confused. Because there are a lot of different options and command for each tools, which I'm not aware of. I'm going to go to that part just a bit later, but I'm just explaining the reason I'm using the VS Code as my terminal. There are some drawbacks for using VS Code as a terminal. One drawback is VS Code is kind of slow, but there are also some advantage of the when you use VS Code as your terminal. One advantage is, of course, the major advantage here is that I can use GitHub Copilot right here, and I think it is a good way. And if you are not you are a beginner, I encourage you to do the same, because GitHub Copilot has an educational. You can use the educational version for free, as long as you are a student or a faculty for in a college or in any other schools. So why not use it? It is useful. Some people prefer Cursor AI more, and arguably Cursor AI is better. But as a student, you can use it for free. So that's one settings you can consider. Okay, so let's walk through the commands that list in the course website. So I'm opening a window in another monitor to see the command because they are ordered in some sense. Okay, first we are going to the most basic commands that you should use it to survive in the command line. The most basic command is cd, which means cd change dir, change directory. A directory is kind of like a folder, if you are familiar with the terminology in Windows. So, okay. Okay. Never mind these commands. I'm just trying to install a command so that you can visualize the directory structure of a file system in Linux. In Linux, it always has a file system. It kind of like a tree. It kind of like a tree. Let me go to the root. So, okay, it's just too big. So I'm giving you an example to using compiler here. How do I use tree command to list files, list the directories? Okay, so I want to limit the recursive depth of tree. So I just ask a question here, and it gives me a suggestion that using the option -arrow3 to limit the recurrence depth, search depth of the tree. So I'm using this button to insert this command into my command line. Into my command line here. Okay. Let me Control L it again so that you can see it more clearly on the top. Then I run this thing. There's still too many levels. Let me just make it like one. Okay. So the file system is like a tree. Mostly like a tree. Technically, it is not a tree, but in most of cases, it is close enough to a tree. So we have a root directory, and we have many subdirectory and files on this root, and each subfolders or subdirectories, you can have a subdirectory of its own. Each subdirectory can contain some files and subdirectory of its own. So basically, it is a tree structure, kind of like it's not that different with the file system in Windows, except Windows has a C drive, a D drive, or other E drive. But in Linux file system, or other Unix file system, it has only one root. It doesn't have other drives. It just has one root. So if you have another, say you have two hard disks or some SD, then how do you access to them? In the file system of Linux, you mount this drive to a subdirectory. So the root is probably lives in a partition of a hard disk. When I say hard disk, it might be referred to the solid state disk, but I'm just calling it hard disk, or maybe I just call it a disk. So the file system in a PC or in a computer, usually we bought a disk, either a solid state disk or a hard disk. Then we make partitions to separate this hard disk into some subspace. And each partition is kind of like logically like a drive in the Windows system. So in Windows, you can just put one hard disk and put it into your computer and run the partition tools. Then you get two drives. and maybe you can get another solid state drive, solid state disk, and making like 2 or 3 partitions, and each of them is logically configured as a drive if we are using the terminology in Windows. So in Linux, the root file system, the root is lives in one of the partition or in one of the drive. Other drives or other partitions can be mounted as a subdirectory in the file system. So that's a logic. But logically, your file system just looks like a tree. So we can use some command to see where we are. One command is pwd. So currently you can see that I'm at the root directory. So we just got a slash right here. So which means root directory. And I can go to my home. I can use the cd with any argument. I will go to my home directory. Then I use pwd to see where I am. So I'm in home tjw. So that means I am in a top level subdirectory home. And in the home directory, there are many different subdirectories, but I'm in a subdirectory or subfolder tjw of the home directory. So you can see we can use this command to just navigate through different part of the system. So I can give an argument of the full path name, like home. Then I'm going to the home. So you can see the prompt here gives you a hint of where you are. This can be set in your system environment or in your home environment, but this behavior can be changed. But this one is a popular setting, so that because we usually we know where we are before we can do any other command or things. Otherwise, it would be very confusing or dangerous. But no matter what, you can use the command pwd to see where you are. See, I'm in the home's top level subdirectory home. I can use ls to see what folders or what files are inside in the current directory. So you see, it only has one subfolder, which called the tjw. Then I can change to this subdirectory. As we have mentioned, we can simply type cd because home/tjw is my home directory. So in order to make things more convenient, I can go to my home directory by just using a cd command without any argument. However, there are many different ways to access to this subdirectory. One is just like before, we give full path name, then we go to the home directory, and you can see that it shows a tilde right here, because the tilde usually means just a shorthand for the home directory. So I can also use cd tilde. I'll go to the home directory. Let me go to root directory first to show you this actually works. So you can see it becomes tilde right here. Also, I will explain the dot later. Also, if I am in the home directory, I can use cd tjw to go to the subdirectory. This is called the relative path. So without using giving the slash, so I can just simply give the file name tjw. Because currently I'm in home. So tjw means the files that in the current, the folder name in the current directory. So I don't need to type the full name. I simply type the tjw is enough. So it makes things easier. So let me see how many files are in my directory. If I use ls is to list the files here. Then you can see that I only have an output.json and src subdirectory. You probably can find the difference between these two file names. One is blue and the other one is white. This is because we can set some color scheme to the files that list with ls, and in this case, the blue happens to be the directory, and the white characters happens to be the regular file, just a regular file. So I can easily tell which is a directory and which is a regular file. But this coloring is not universal, because this is just my setting, which is sort of a default setting because I didn't change it much. I didn't use my WSL much. I use Docker inside the WSL to run some service, but I rarely touch the files in my Windows subsystem Linux recently, so you didn't see many files in this system. So I believe this one is default settings. However, it is not reliable because everybody can change this coloring scheme. So is there another way to more reliable to actually see the file properties? There's one way to do so. You can use ls-l. -l meaning I forgot the meaning, but it means more detail. But using more detailed things to see it, to see more detail. So let me explain what is here. So these numbers right here is the size of this file. For a regular file, this number is exactly the size of this file, how many bytes it contains. So what about src? src is a folder. Why does folder even need a size? Because a folder still needs to store some information. If you need to store some information, then it will occupy some space in the disk. So it indicates how many space is used by this src, the src subdirectory. Because in this subdirectory, it doesn't have many files in it. So this size 4K is the is a minima, probably the minima size allocate for a folder. If I put many files in this subdirectory, this size will getting bigger. But right now, let me use src. You can see there's only one subdirectory inside src. So this 4K is probably just the minimum requirement to allocate a folder. Okay, usually you don't need to worry too much about this number if it is a folder. But it comes time that you will find it this might be useful because you can probably guess the efficiency of the file system if you see this one is too large. Okay, then what does these two means? TJW and TJR. The first TJW means the owner of this file or this folder. That means the user TJR, which is myself, owns this file. So other people does not have the fully access to these files. So some access can be only done by the owner. And the second TJW is the group. A group can contain more than one user, and a user can be a member of different groups. But the second TJW means we have a group called TJW. It is automatically created when we create a new user in Linux. So each user has a group of his own, but we also have other groups like a Docker group or other like the sudo group, which has different meanings. But here it means these files belong to the owner, the user TJW, and belong to the group TJW. This means the last modified time of this file, and of course this is the file name. So how about this mystic characters at the beginning of this file? This is a representation of the property and access control of this file. You can see that the first letter D means it is a directory, and we have a dash right here. It says that it is just a regular file. There are other characters in the first place. Sometimes it can be a L, which means a link, or maybe a S, which means sudo. But in the most case, you will see a regular file or a directory. And the next three characters are RWX. We in fact have three sets of RWX. You can see that we have R-X, R-X, and RWX. The first RWX corresponded to the user of this file, the owner of this file. And the second set of three characters, RWX, corresponded to the group of the file. And the last three RWX is corresponded to every other users that is not in a group or not the owner. So you can see that RWX here means I myself can read this file, can write to this file, and X has different meaning for folders and for regular file. For regular files, it means it is executable files like a program that you can run. In fact, a lot of different command line tools are a program. So given the X access, then these files can be run as a program files, as executable files in terminology. So this is for the security reason, because we don't want the user to run too many different things, or we don't want the user to accidentally to run some things, run a files that is not supposed to be treated as executable, because hackers will have a more easy life if every files can be executable. So by marking a files that is not executable, it can prevent us to mistakenly running a file. Okay. For a folder, the X means we can enter this directory or enter this file folders by using the command cd, or using any other ways to change our directory, change our location to this directory. If it doesn't have this X, then we cannot go inside this directory. If it has a R access, then it means we can list the files inside this directory. And when we have a W access right, then it means we can create a new file or delete files inside this directory. Okay, so we have basically this is a kind of ancient or primitive access control, but it is still quite relevant and useful. In more modern Linux or in Windows, they actually has a more advanced access control system, more refined, the more precise controllable, and has a lot of more functionality. But a lot of systems still respect to this simple or primary type of access control. So at least when we're using LS, we can still get this the access right of these files. But in some more secure or modern system, although they might still have the same like you can see still see the same thing, but they may surprise you because underneath they have another access control system. But I mean, in most of the case, this still apply and very useful. So now you know how to make things secure or make things more to control the access right and separate it to so that one user can access it and the others cannot. So one of the example and you may encounter is for the SSH setting. Okay, so before that, let me give you some more some more argument and options for LS. One option is H. If you use the H options, H means human readable, human. So you can see that the file size becomes like 280K, and this one is 4.0K. This one is more human readable comparing to this long number. So if it is getting bigger, it will have like a mega or giga, so you can easier read the size. Another useful option is LAH. Okay, let me do it again to see what happens. If I'm just using ls-l, you see this directory seems rather clean, has nothing inside this directory. But if I'm using LSLA, then you see, okay, there are a lot of files. There are in fact a lot of files in this directory. Just we didn't saw it. We didn't see it. The reason is in the Unix file system, in particular Linux uses it. In the Unix file system, it is a convention that if a file name starts from dot, then it is considered to be some kind of special. In most of the case, it means this file is a hidden file. Or why does it require to be hidden? It is because it is sort of important or has some meta information inside it. So you can see that we have a cache file, a bash RC, which configure the behavior of our bash environment, and the .ssh, which is contain the configuration of the SSH, like the private key, public key, or the host. And so this and .cache and .config and .local, they all have their special meanings. Usually can be override the system behavior. Like .local, you can put some your fonts, like text fonts inside it, so that you can use instead of just using the system fonts. Okay, some of the more special file name is the dot and dot. These two, the dot is in fact the directory itself. So if let me show you here. Currently I'm in home TJW. If I cd dot, then it does nothing because I'm changing to the current directory. I'm not moving to anywhere. I'm just moving to here. I'm not moving to anywhere. So dot is just means the current directory. If I ls dot, I get to list the current directory. Same as doing these things, or same as doing these things, because the dot is currently home/TJW. Then how about dot? The dot is the parent directory. So currently I'm in home/TJW. So my parent directory is home. My parent directory is home. So I can cd dot to get to the parent directory. I'm using H here. So it is really clean. It just has dot and dot. Every directory has a dot and dot because the dot is itself and the dot is the parent directory. So even for the root, it still got a dot. So what is a dot? What is a parent directory of the root? We can check. It is itself. You can even see that the timestamp or like the size or everything is the same. But because every other folders have some, apparently they have a parent directory. So it makes sense to make things more consistent, so that the root still have a parent directory, but the parent directory is itself. So in fact, if by consider this sense, the file system is not a tree because the root has a parent. So we got a loop. So it is not, by definition, it is not technically a tree. But they are similar enough. Okay, another useful but shorthand is the dash itself. Let me go to my home directory. cd dash means go back to the last directory. So let me make create some directory here. Let me go make directory like dir1 here. Then I change my directory to dir1 and see my full path to be home/tjw/dir1. I can change my directory to directory 2 by one way to do that is home and directory 2. But I don't have to do that because I know my parent directory. The directory 2 is in my parent directory, so I can simply go to my parent directory, and the subdirectory dir2 of my parent directory. So this means it. So why the data even exists? It is because it not only allows you to access to your parent directory. By combining with other syntax, it can be very, very useful. So I can go to the directory 2. Then I can use cd dash here to go to directory 1 because I was coming from directory 1. So in a lot of times you are switching between directory. Sometimes you just want to go to another directory to do some things and go back to the major or the main working directory. This happens a lot of time. So you can use this one shorthand to be, it's very convenient. And I can go back to directory 2 again and go back here using this guy. There are some more advanced command, like you can use push D or pop D, things like this one. And there are a lot of different ways to manipulate the navigation history, but they belong to the more advanced scope. I'm not going to cover right here, but there are other ways to memorize more directory, and you can navigate to a lot of those different places really quick. Just so you know, there are ways to do that, but just like I said, it is beyond the scope right here because we are only going to introduce more fundamental and the basic commands. And the other thing is I'm not that familiar with that, so I'm assuring you that you can survive without those commands. Okay, so that's one thing. Just one more note that you can use, combine this data together. This means we go to the parent of my parent. So in this case, I'm going to home. Let me go back and let me show you the directory. Because I'm in here, dir1, so I can go to the parent of my parents, which is the home directory. And of course, I can go to the parent of my parents of my parents. In this case, it's going to the root directory. So you can see I'm going to the root directory. Okay, so this is so much about the navigation, CD and LS. Just a side note that LS has a lot of different options. So let me go to a more rich directory. So what if I wish to list these files and not this one. So here. So we have a lot of different files here. So what if I wish to kind of list this file but sort them by the file size? List can do it. What if I wish to do that and sort them by the date, the date time here? It can do it. Else can do it. So one way to do that is to use a traditional way to read the menu. You can use Google or use built-in menu called the MAN. MAN is like the human man, the mailman, male human, but it is in fact the shorthand for menu. So I can use man ls to see the menu of the ls, and you can read through it and figure it out yourself. Or another way to do that is using info ls. You can get another type of menu. This is more like a GNU style, and the man is more like a Unix style menu. But both of them are just menus using different style or preference. You can also, a lot of commands allow you to like --help. Then you can find a simple version of the menu, or ls-h. In this case, it is not working. Sometimes -h refers to the help, but in this case, of course, we know it is corresponding to the human readability. We just introduced that options before. Sometimes you can use the question mark, but not here. I think it's more common to just use -help, and you got this simple version of things. However, as we probably hinted before, the most convenient and maybe modern way to do that is to use an AI. So let me just ask you, that's UI. For this kind of simple task, the AI is, I think it's quite reliable. However, in some case, it can provide some wrong answers. So use it with caution. But in this case, I'm pretty confident it will get me a correct answer. So how to ls files and sort by modified, last modified time. Okay, so let me make it bigger. So you can see that you can use LT or LTR if you want it to be a reverse order. So I click the icon again and get it inside my terminal. And you can see that maybe I should just add an A here to have more files involved. So you can see that it is actually sorted in ascending way. Okay, so that's about the ls. Now let's go to more commands, more common commands. So one of them is touch. Although you probably won't use this command often, but I'm introducing it right here because it is a really quick way to create a file. Just you may see that mkdir, that is a shorthand for make directory, can create a directory. So how do you create a regular file? You use this one, touch, like abcd. Then you see we got a new file called abcde, and this file contains nothing inside it. You can see the size of it is 0 because there's nothing inside. We just touch the file. It is really useful in many situations. So one thing you want to make sure you can actually create files inside a directory, because sometimes, although we can read the access rights to know that we probably has the we have an access, read access, so we can write access, so we can actually create a file. But sometimes it is more directly to just create a file and try it. And sometimes even if you have the writing permission, you still cannot create a file because maybe the disk is full. It has no space left. So it will help you to quickly to address the issue. Okay, because if the disk is full, when you try to create something, it will show you an error message that it cannot be done. Or sometimes because you are working in a network or remote drive, so there has some network issues. So there comes time that you need to quickly create a file in a directory. And sometimes using this, it will trigger a watchdog or some monitor, file monitor. Because sometimes you want to reload your server or something. You can just use this one to just have some change in this folder, to just make some change in this folder, and it will get things work. So anyway, it's just a tool and very easy, very simple to use. So it does not appear to be very useful at the first glance, but after you're familiar and when the times come, you'll find it maybe useful. Okay, other way to create files or to change file is like one of them is MV. MV is to move files. So I can move A, B, C, D, E. You can see that I am hitting tab right here. So it can auto-complete in the bash, in this shell, because it knows the things that follows MV must be a file name. So I hit the tab, it will auto-complete these things. So let me move this A, B, C, D, E to another directory, like dir1. Then it is done. It is not appear here. And when we go to dir1, we got A, B, C, D, E. We can move it to dir2. Then we can see the file. We can move it to a parent directory. Another common use of this MV command is to rename a file. Because if you're using the Windows, the DOS or CMD, you probably knowing that rename is a command. There is a command for renaming file and another command for moving files to another location. But in the Unix shell, MV does both. We can simply MV ABCDE into something like a rather long. I probably should not use the character only. Okay, so we got a file name. Okay, so how do we so we got an MV. So how do we to see the file, the contents in this file? One way to do that is using cat. Because there are nothing in it, so we see nothing. But you can see that I was using the tab to autocomplete the file name. This is particularly useful in this case because the file name is so long and so meaningless. So I just type the initial H and type the tab, and then so it kind of emphasizes the usefulness of the auto-completion because people use this all the time. Let me move this one into called ABCDE. So another way to create a file is using cat. Not only cat can show the contents of a file, it can also it can also show the contents that you were typing in. So basically, if I give no argument of cat, it will go into a mode that is taking input. So I can do, let me do it again. Like, this is a pen. So you can see that when I type this is a pen, and when I hit enter, it shows this is a pen again. And when I type the other line, this is a book, and I hit the enter, the cat, it shows this is a book again. This is because cat is simply taking an input and showing it, redirect it into output. And if you don't give it any argument, the default input is your typing input, and the default output is the console itself, just the terminal, what you are seeing. And because the input of the terminal or the shell is buffered, which means that it only input to the into the program or the code or any executable only after I hit the enter. So that's why when I type this is a pen, enter, then it will show out the everything that I just typed. But anyway, if that is too complicated, it doesn't really matter at this point. You just know that what cat do is taking an input and the output, redirect the input into another output. So if I keep typing, how do I stop this one? One way to do that is hit Control C. Control C can break the program, just like what I did. But the more proper way to do that, to end the input, is to hit Control D. Control D here. So in Unix, Control D means end of the input, end of the file, end of the input. This is in the Linux or in the Unix or even in the Mac. Control D means end of the input stream. However, in Windows, the same thing should be Control Z. Control Z means the end of the stream. But you should not type Control Z in Linux if you're not familiar with what Control Z does. We probably will go to that later in the class, but Control Z has a different meaning. Okay, after we know that we can type something and print it on the screen by using cat. One way to do that is to use it to create a file. Let me create a file 1 here. So you can see that we have a greater than symbol right here. This in the shell, in a base Unix shell, this greater symbol means we redirect our output to this file. So instead of showing everything I type on the screen, this is a pen, enter. This is a book, enter. It will redirect the output into that file 1. So after I hit Control D, you can see that we already create a file 1. And the size of file 1 is 29 bytes. So how do we see the contents of file 1? We can still use the cat file 1. So currently the file 1 is replacing the default input, that is the keyboard input. It replaces the keyboard input. So the cat will take the content of the file, or contents of the file 1, as its input. And the default output as the screen is the terminal, the console. The terminology is console. So it will show the content of the file 1 to the console. So you can see that it can show the content of file 1 to the console. Another way to do that is using this less sign, like the mathematical symbol, less symbol. Use this symbol. This means we redirect the content of file 1 as the cat input of cat. It works the same as before, like this one, cat file 1, because cat will take the file 1 as the input content. But in the shell, it will always use, when you use this symbol, the less symbol here, right here, it will always treat the files after this symbol as the input of the program. A more civilized way to see the content of file is using more file 1, or using less file 1. The reason that we need to use more or less is because they provide some control so that you can read the file one page by page when the file is pretty large. When the file is pretty large. Let me use the cat to create a rather big file. So when I cat file 1 to file 2, the file 2 will contain twice as many contents of file 1, because this is the first file 1 and this is the second file 1. I can do the file 2 into file 3. And also I can do, similarly I can do file 3 into file 4. So I already got some big files, but let's do it again. To file 5. Okay, so one tools that you can use to examine how many lines of this file is using WC, which means word count. WC file 5. You can see that we already get a file with 240 lines and 960 words and over 3,000 characters. I still think this is not large enough. Let me do it again. Let me make it 5 times larger to become file 6. And we use WC to see file 6. So you can see that as files times larger, it becomes 1,200 lines in this file. So if we use cat to see this file 6, we'll get really fast showing things. Although a lot of terminal support the scrolling, so we can scroll up and see the content. But a more civilized way to do that is using more file 6. So you can see it page by page. You can even do the search by using slash. So more is a standard tools in Linux. However, personally I use less a lot. There are some more modern newish tools, but less is still pretty good. We can use less to see it. file 6. Because not only you can go down, you can go up. You see, you can go down and go up. There are a lot of different shortkeys, but you can see the menu, kind of like the vim, but that is totally another topic. But one way to do that, one particularly interesting feature is to do the search by pressing the key slash and say book. It will find out all the books it finds, and by pressing N, you will because it has too many repetitions. So, but by pressing the key N, you can go through it to the next one, next book and next book and next one. I can go to the pen here and search through the next or previous one if you press the P buttons to do a lot of different ways to navigate the files. So this one is a pretty good way to see the things. Let me go to the SRC and to find some files here. So for example, if I'm trying to do what I'm trying to do is to let me go to the SRC and see things. Let me just show the CLI PY files. So you can see that I can go to see to find if there's print. Yes, there's print. And I was using the key G. It will go to the top, and I press N. It will go to the next print and the next print. So if I want to find the ADD, you can see that it can press by pressing N. It will search through the document, which is pretty good. There are other there are other tools to show things, like I think Batcat is one of them. Let me install it. This command is used to install things in Ubuntu or in Debian. So apt is the default package manager in Ubuntu traditionally. Okay, so one of the modern tools that I'm going to introduce is Batcat. Okay, so it is a replacement of the cat, so that you can have a color highlighting, syntax highlighting for files, especially for the code, like a Python code or C++ code, or maybe JSON. So it is a replacement of cat or less or more, and so that you can see things more in a more pleasant way and more clearly, because it has syntax highlighting. So this is one of the modern tools that replace the traditional one. But it's still good that you can knowing the traditional or more standard tools before, and so that you can appreciate these new tools and knowing what kind of the issues that these new tools is trying to solve. But another modern tools that can replace the LS is like EXA. So you can see that it is more colorful. I can ask the Copilot to like how to show the color name for or header. We should show the header using EXA. in fact, the tools I'm using is EZA, but it's compatible with EXA. It is a replacement of LS, and it can have more prettier output than the standard LS. So, for example, the Copilot just told me that I can use the option header, so that when see things, it will has a header. So remember that we were explaining the meanings of each of these things. The EXA provides an option called header. It shows, okay, these are access permissions, and this is a size, and this is a user, and this is the date modified, and this is a name. It provides more clear clarity of the meaning of what the list of the file, and it also provides the backward compatibility with LS. Okay, so we still have a lot of more tools that we can introduce. You may want to check the list on our course website because we definitely cannot show every command. So let me show you a few more. So one of the useful things is echo. Echo is like a print in Python. So I can hello word. So I can print it. So one way to do that is to use it with the redirection, the output redirection to file X to the file X. So the hello world is into the file X. Another command is date. It will show in the system datetime, current datetime right here, and it can also help you to set a datetime. I'm not going to detail. There are also some tools that you for typical tool or more for Unix tools that is famous for helping data scientists to do things or developers to do things. One of the tools is called the find. The find is going to search all the files and the current directory. It has a lot of options that I don't even remember them. Let me ask the Copilot. Suppose I want to find all the Python files. How do I do that? So how to use find to search all files with okay, so you can see that this is a command here. Like this means the type of the file is F, and the name has this pattern. That is anything this is a wild character. The star means a wild character. It matches anything. One thing need to note is that the find has a different convention of the argument, because you can see that it has only one dash right here, but it definitely the type is a word. You can see that in LS or in any other like cat or less or other things. If we have a single character options, then you can use one dash. But if you are using a style that has a longer option name, argument name, like a type or name, you usually have two dashes before this argument. But for find, it uses only one dash. So it's kind of strange. But you can see that it finds all the Python files in here. I can also find the files that has a size greater than. How do I find search file that is larger than say 1K. Okay, so you can see that you can use this command size plus 1K. Maybe 2K. Okay. So these are really big files, like 20K. Oh, still got something. Like, okay, that was really big file. Okay, let's see these files to make sure it is really big. So you can see this is actually a really big file. Let me use LH. So it has this turtle.py. In fact, it has like 141 kilobytes. So it's a really big file. So find is a really useful tool to search the directory. Sometimes I use find and I didn't even bother to use Copilot to ask a rather correct way to see things. I use something like find. Maybe I use another tool called grep. If I want to find some files that the file name contains turtle, I use grep. Grep actually what the grep does is to take the input of it, take its input, and let me first do say file 1. Grep. Let me grep like book and file 1. You can see how it works. It actually find the pattern. In this case, book in the file. So in Unix, there's a way to combine two commands together. Like if I type file 1 and I want the output to direct to the grep tools, so I can use this pipe, the vertical symbol. This means the output goes to the next command right here. In this case, it's grep. I can still use this guy. So they are pretty much has the same meaning. Okay, so let's combine this find with this grep tools. If I grep turtle means the find just lists all the files in this directory, and I grep turtle. So every file name contains the pattern turtle. I will get the output. So you can see that it is pretty quick. Turtle right here. Except for something that access denied, I actually got these files like turtle and turtle.py. Another tool that is useful as let me check. Diff. Diff is used to find the difference between two files, which is very useful if you made some change into a source code and you wish to see, okay, what did I do? So imagine that you are doing two experiments. In your mind, these two experiments are pretty much the same. And you have one Python file for the first experiment, and the other files for the second experiment. So you can use diff to compare these two files. Let me do a simple example. Let me copy file 1 to file 1p. Maybe use file 2 to file 2p. Then I use an editor called vim. I'm not going to introduce vim right now, but I'm just using this to edit this thing. So I put 1 right here. So make a modification like this one is book 1, and this one is pen 2. So when I use the command diff file 1, file 2, and file 2p. File 2p. It will find the difference. So it turns out this means that in the second line to the third line, in the first file it is something like these two lines. This is a book and this is a pen. But in the second file, it becomes this is a book 1 and this is a pen 2. So it can find the difference between two things. If you are not worried about the difference, you only need to want to check if they are same. You can use CMP, file 1 and file 1. Then it returns nothing. If they are different, then it will show that they are different. So CMP is another tool, but I think diff is more useful for developers or data scientists. Another common way to use diff is that, okay, we have two experiments and we have a log of the experiment. Then we can compare the log, the first log and the second log to check what difference between the first element and the second element, the first experiment and the second experiment. There are some data tools for the that is really useful. One is the head that only shows the first 5 lines of a file. For example, the file 6 is really large, but if we use head file 6, then we only get the first 10 lines. The similar is a tail file 6. It only shows the last 10 lines. If we combine with the find, then we can only show the first 10 results. We can show the first 20 results if we give an argument. And we can change it to the tail to show the last results and last 20 results. It is really useful to examine the data files, or sometimes you wish to combine it with the output of other command. Okay, another useful tool is sort. As the name suggests, it sorts the files. So for example, we can sort file 6. Because a lot, maybe we should sort the file 2p. You can see that it will sort the results. One thing I always do is that it may not be the best way to do that, but a tool called DU can compute the usage of all files. So for example, I use DU star. Or DU, maybe I should just use DU star. It will compute the size of different things. So if I combine it with sort and making it numerically, then you can see that I will find the size of each file or directory and sort them by their size. So I can find the directory that is has more allocated more space, and by combining it with less, I can have a really good way to fill the information of directory. Of course, you can also use the find with less, so you can to browse all the files. But a modern way to use this thing is use a fuzzy search. Okay, so let me use find and FZF. The thing is, it can search the things with more relaxed pattern. So for example, I want to search something like say L S H A R E R and S T or like OV. So you get the idea that I can put something like LSH means I can relax the search condition and quickly to find out the things. So even if I didn't remember or the full file name or just have a really fake file idea of what the file name is, I can still find out in the directory. And the best thing is after I select the file I find and press enter, it will return the full file name here, so that I can send these files into another process next step. Like maybe I can open a file and fill this file or do something like. Okay, so here is a, but FZF is more like a more newish tools, but because it is so popular, so I'm introducing it right here. But it belongs to the newish tools section. Okay, there are still a lot of different tools. So if I have time, I will introduce them one by one. But feel free to, if we don't have time, feel free to see the list in our course webpage and check them one by one. And because we have a tool of Copilot Chat, so you can actually ask what it is. So for example, you can ask it like what is unique. It will explain it to you and even give you some examples. So unique is actually finding a unique element in these files. So even though that the file 4 is so big, but you should sort it first. So so first you sort the file 4 and you make the output into unique. Then it will filter out all the duplicate entries and give you the only unique lines in the files. So although file 4 contains a lot of lines, but it only contains 2 unique lines. So we can use this tool to find out. Okay, just check the list and ask the Copilot, and you will see there are a lot of useful tools in our in a basic CLI and shell command section.